Hello
Hello
guys,
guys,
so I
so I
think
think
I'm
I'm
audible.
audible.
Can you
Can you
please
please
confirm
confirm
if
if
I'm
I'm
audible,
audible,
guys?
guys?
And we
And we
can
can
wait
wait
for
for
people to
people to
join.
join.
Okay.
Okay.
So
So
my
my
voice is
voice is
echoing, is
echoing, is
it?
it?
Let me
Let me
see.
see. Now is it fine? Like, is it fine now? Should be fine now, I think. Okay. Yeah, so good to go. Okay, guys. So we can start off, right? So the audio is fine, the video is fine, I guess. Cannot see you. Just 1 second, it'll load. I think you can see me now. Okay. Let's wait for some time for people to join and then we can start off. Okay. So so guys, so as you know, I am Sanchit Kulkarni and okay, wait, how many people? 1 second. Okay. So right, like first I'll talk about myself and my experiences and then we can get into the interaction mode. So as you know, I'm Sanchit Kulkarni and I'm currently working in AMD and I work for AMD making currently making 3 nanometer chips and I've also worked in Honeywell Aerospace and then uh, had my internship at ISRO, eYantra, IIT Bombay, and all that. So, I'm going to discuss all about that. Okay. So, first of all, uh, briefly, if I have to tell you, so, like when I started my internship at ISRO, it was like quite interesting. And the main thing about ISRO is like, okay, first I'll say you like how I applied and how I got ISRO, right? So I normally applied it from their website, and then I just got also I requested for a referral, right? And hopefully I got a referral because I knew someone inside. And yes, in ISRO you require someone, if someone is there who can recommend you, you can actually get an edge. Most of the people who get in, like for an internship, you need someone to recommend you. So that is or normally also by just applying also you can get, but the chances are quite less. But if someone recommends you, or you can say a referral, your chances obviously increase, right? So I worked at ISRO, and ISRO's experience was it was quite interesting and quite fun. But there was a lot of security there. Like we had to keep, like there was a lot of checking at the entry gate, and we're not allowed to take our phones. We are not allowed to take any kind of electronic gadget inside, and there's a lot of checking there. And so first, I think for a few days there was a training, because I was just in my second year. So there was some training for electronics, basics of electronics and all that. And then later they guided us, like what they do and what other facilities are there. And then there was a basic interview where, to decide where they're going to put us, in which team we'll be and which part of the team we'll be working for. And obviously there'll be a lot of agreements or non-disclosure clauses and all that. And then of course I cannot reveal on what I worked there. And anyways, they don't give interns that critical work and all. It's more like you get to learn how ISRO works and how it operates. It's not that you basically it's like your learning phase. ISRO does not have much benefit on that, but yeah. uh, but you get to learn a lot. Okay. And mm, so basics of electronics, we were trained on that, and obviously programming and all that, and then we started working. And yeah, ISRO was quite interesting. I learned a lot of things there. And then coming to the third year, I participated in eYantra, which I participated before also, but I did not get in. But in third year, we somehow had a proper team. We had a good team. We had two people from CS and two people from electronics. And then our topic was balancing the bot, right? So that balancing board. So eYantra is like eYantra is actually a very great platform for your internship. It's done by IIT Bombay, and it's very good, like and I will always recommend you to explore eYantra. You can, I think any college can join. There is, like, you just have to, first there'll be different rounds. So I think first there'll be multiple rounds, and then there'll be a final winner, and the winners get to have internship at IIT Bombay. So that's how it is. So our theme was, there'll be different themes. So our theme was of balancing a robot, and it was mainly control system, as I've told you, right? So it's all about PID, and C programming, obviously. And the whole kit they'll provide you. So initially you will have some rounds, like you'll have some exams about it, and you'll have to qualify those, and they'll keep on giving you tasks, and you have to do that. So best combination I recommend for eYantra is, say for 4 people, have like 2 people in CSE, and 2 people from CS, and 2 people from electronics. Even if you have 4 people from electronics, that's fine. But if you have, like, say 2 people from CS, it's like a good thing, because they're obviously better at programming, so your team is stronger. Then we qualified the rounds, and then finally we were selected as the finalists. And it was all like, you'll have all the obstacles, like, so your bot had to go on, like, say inclined wedge kind of a thing. And then your bot has to balance there. So they check how well you're balancing the robot. So it's all about the configuration of P, I, and D values. So it was great, right? It was fun. Mm, and then you have like competition. So obviously if your robot is well balanced and it's better, you have a better edge on others. And that's how we won the competition. I think we finished at third place there, like all over India. um, and it was and then there was a basic interview. Once you are like in the top finalists, you will have interviews, right? So if you again pass that interview, uh, you can get a internship there. So then I passed the interview, like all of our teammates got through the interview. And we worked under Professor Kavi Arya. He's a faculty in IIT Bombay, I think from CS department. So a great faculty from IIT Bombay, Kavi Arya, Professor Kavi Arya, and we got to work under him. So we were mainly into audio and ML kind of a thing. So that was a very good experience there, where I learned AI and ML models, and I got a how we basically built the AI and ML model for voice recognitions and all that. So it was cool stuff. It was good. Later, you also get to choose your themes, like what you want to do there, like in the internships. So mostly people will be working under Professor Kavi Arya and all that, right? Then later, eYantra, like, see, if you have to go to, like, say, foreign, any foreign university, right? So like one of my teammate, he wanted to go to CMU, right, for his further higher studies. So the best thing is having a recommendation from people from IIT Bombay, ISC professors and all that. So eYantra, if you have to go abroad and study, right? So eYantra is a great platform to participate. So yeah, if you have a recommendation from, especially from Kavi Arya, right? It can be great. It can be really great. So you can get into top university. So one of my teammate got into CMU because of the recommendation there, and eYantra obviously had a great role in his resume, right? Then coming to India, right? Like Indian core thing for MTech, you don't really require much of the internships and all that. So you'll have to obviously prepare for your GATE. So again, I prepared GATE. We had COVID that time, like 2020 lockdown. So I got to prepare from home while the online classes were happening. So I had a plenty of time because you need not go to the labs and all that, right? You can just sit at one place. So started preparing for GATE, like 2 to 3 months properly prepared, and I think I got a percentile of 98% or something, 98 percentile something, yeah. And that was good enough for me to get into BITS. I could not get into IITs, and BITS had a pretty good placement, so I just took that. And then so then got interested into VLSI, chip designing and all that. So before that I missed out Honeywell, of course. So after my BTech, right, I got opportunity. I got placed at Honeywell Aerospace, right? So Honeywell Aerospace was great, right? Honeywell Aerospace, you get to work all your components in Boeing's, right? Like as I said in many of my videos, right? So the components in the aircraft, the say APUs and many of the components in aircrafts are done by Honeywell Aerospace. So that was like crazy experience there. So you get to see, you can also simulate whatever you do, right? The stuff you do there, you can simulate it in a real aircraft and check. Okay. And of course the safety protocols there are very high, because of course that goes into the aircraft. So if right, there were like 2 crashes because of Boeing, and all that was because of some electronic component which went wrong, right? In Boeing, both the crashes. That was not done by Honeywell, it was done by Boeing itself. But yeah, so the point is, your electronic component is so important there that any misconfiguration or any mistake in the design might, or any bug in the design might cause fatal injuries or something like that. So that is like very important. So then there I got to work on, like, mainly I was working on controlling the motor, DC motor, like to particular angle. So it was all control system, it was coding. Of course you had to code and control the motor, like I've told in my videos also, right? So you have to adjust PID values, okay, and then you have to configure it, and then you have to control the motor to a specific angle. So that motor will go into the flap systems and many other systems that they had not told or disclosed properly. But yeah, so in Honeywell Aerospace, my interview experience, so that was an embedded role, right? So for embedded role, they're more focused on C programming. Okay, so they were very focused on C programming. They also asked me questions of assembly level programming, right? So they were interested, because you'll have to do the boot up also. So basically you initialize your microcontroller to some values also. So you will have to know a little bit of assembly programming, because see, assembly programming is like the fastest way, or basically it is C programming only. So C programming, a niche level towards the hardware, is assembly programming. So assembly programming is very, very important, right? For me at least, like at that time it was very important. And they asked me questions on assembly programming, but mainly it was focused on C programming. So in the coding questions also, they'll give you something related to C programming, and you'll have to do things like bit manipulations and controlling the bits, all that stuff, right? So that is like very interesting. So basically they concentrate on C programming and digital electronics. So from electronics they see basics of analog, digital electronics, and C programming mainly. So this is the thing what they see. And they'll ask you protocols and all that. So at that time, I think in round 2 interview they asked me protocols. But before that, to clear your initial rounds, the basic, that's your C programming, your what do you say, your coding skills, that's your C programming again, and your digital electronics and your analog skills. So analog basics, like what's op amp and all that. Not, they didn't get into much detail for analog. I don't know which companies get into much detail for analog, but at least Honeywell did not get into much into analog, but more of digital, and basics of digital electronics, computer architecture, and C programming. That was like the major thing where it got was concentrated. My interview was revolving around them. And of course my projects they saw, right, it was all based on control system. And also of course they asked more questions on control system. How can you control the robot, like how do you control the motor, what values of PID, how control system works, what's a stable system, what's an unstable system, and all that, right? So yeah, that was fine. Like if you have your good basics, right, if you have good C programming, if you can do bit manipulations, if you can write basic assembly programming, and if you know basics of electronics, I think as a BTech level you're good to go into the companies. So of course I'll upload the proper roadmap for embedded industry. For that, make sure you've seen my all about embedded systems, right? So if you've seen that properly, you will get a proper idea about embedded systems. And also embedded systems, there are multiple people, like people in embedded, they work in semiconductor industry, as well as people work in the consumer electronics. So in semiconductor, it's more about bringing up a processor, bringing up a microcontroller. So you're working more on that side. And consumer electronics, you just use the microcontroller and build a system on top of that. So I've seen both the sides. So in the roadmap video, we'll properly discuss, which will be coming up next. So we'll properly discuss how what all you have to concentrate more for semiconductor industry, and what all you have to concentrate for your consumer electronics industry. So embedded, you've got it covered. Don't worry about it. But I'm telling you again, like I was browsing through the YouTube, right, for embedded, and there were very few authentic channels for embedded, I felt personally, because there are people who will tell you that there is do something for embedded C versus C programming and all that stupid things. But I've clearly mentioned that in my video, so watch that properly. And roadmap video, of course, we'll see properly all the things, how we can prepare and all that. But trust me, working in embedded and working in those real life situations, it's amazing. Then of course, then I cleared my gate. Then okay, Honeywell was obviously it was very good. And then but then I got into bed. So I wanted to pursue a higher degree. So kind of course left Honeywell. Then did my masters in bits. It was good. And there, the main thing about especially masters in tier 1 colleges is like you get to explore a lot of things. So I had a mainly embedded background. So mainly I was into programming, firmware, and all that stuff. But there I went, and then I got to meet professors who are more into VLSI design and all that. So you get to explore things, because see, when you are just a BTech pass out, you're just what, 21, 22, right? So you're not that mature enough that what you want to do for your life and all that, right? So I personally recommend to take some time out and see the fields around you and decide what you want to do. So I personally felt that I was more, I when I started exploring VLSI, I loved it. I really loved it, and I was very fascinated how a chip is made. So when I went into bits, I got to explore VLSI design. I worked under like some professors, and it was good. Like we did some, we published some. We did not get to publish a paper, but yeah, we at least attempted and all that. And then yeah, and then after the first year, I started working on my placements. And for placements, as I have uploaded a VLSI roadmap, that's what exactly I did, right? So if you so in VLSI, you mainly have like something called a front end and something called your back end. So front end and back end, mainly, the thing is, in front end you are more of a person who is on the upper layer, right? So you are you are mainly designing in Verilog, system Verilog, writing test benches. If you are in verification engineer, I made like properly a video, right, about different domains in VLSI. You can go through that. So in college, right, when you like, even if it is BTech, right, or your MTech, you explore everything. Like you write from, you have to do a project where you do from, right from your uh, you say Verilog design to your, your final layout. You have to do the whole process. That's how you get a clarity. And it's actually very interesting also. Okay. Yeah, so I started, like, I of course like started doing Verilog in the starting months, and then got to learn a little bit of system Verilog, but not much into that, because system Verilog, not a big difference, just the few data types here and there. That's your logic and all that. So yeah, so if you are interested in like getting into verification rules, then it's a must to learn system Verilog as well. So yeah, so did a lot of Verilog, actually did a lot of Verilog. So there was a subject called, computer architecture, where we got to design processors and all that, right? So we did a RISC-V processor, MIPS processor and all that. So you get to know how your processor works. So no matter in which domain you go, you have to know, like, how a processor works. So it's actually very helpful for you. Then of course, then you go, and then you, the Verilog code, you synthesize that Verilog code, and then you see the layout, and then you get to the layout, right? So you have softwares like LT-Spice and all, where you can actually simulate some of your, like as I've suggested in my projects video, and in my projects PDF. If you've seen, I don't know if you've seen the projects PDF, it's there on the Discord, it's there on YouTube, it's there on Instagram, it's there everywhere. So I have mentioned, like, take a basic, make a basic say inverter, okay, using two MOSFETs, NMOS and PMOS. You get to explore things. You can analyze all the inverter characteristics, all the characteristics properly. It's very interesting. Okay. And yeah, so that is what I did, right? Okay. Okay, so anyway, so later when we did, like, say, I did like Verilog, made systems and all, then did layout and all that, then I understood that I was more interested towards backend, like, more of CMOS, and how the current and how voltage works, and I was interested more into CMOS and all that. One second, I'll just see what happened here. Some error. Okay, I think it's fine. Okay. How is the video anyways? Is there any problem? It says your streaming thing is weak. Okay, yeah. So yeah, I think now the video is fine, I guess. Okay. Okay, so yeah, so where were we? Where were we? Okay, so we first, like, made the Verilog, right? The computer architecture, where we made the processor, and then we synthesized it, right? And then we saw exactly how it is getting synthesized. So you, whenever you write any sort of code, right, any Verilog code, you have to know what it maps to the hardware, and vice versa. So whenever you write anything, because every day, it's, see, for a VLSI engineer, it's three things. Okay, it's just three things. It's area, power, and performance, right? So whenever you, it's just not you just it's not like you just write some random code and just leave it, right? Even a small change in a behavioral code can change a lot of things in your area of the real synthesizable code, right? So when you write in Verilog, it's fine, right? You don't much care. But when it actually comes in the chip, it actually matters a lot. And then backend people will come and tell you, right, that you have not used the area properly, or the timing requirements are not meeting. So whenever you have to know how the hardware actually is working, so you need to know everything, like a case statement maps to a marks, and if else is going as a priority encoder and all that. You have to have, like, clearly you need to know that, right? So that is one thing. So whenever you learn that, right, whatever I'm saying, so while you're learning that, if you keep that in your mind, that will obviously help you, right? So if you see Indranil Sen Gupta sir's lectures, right, so he has clearly mentioned mapping of each hardware to its corresponding Verilog, and corresponding Verilog code to its corresponding hardware. So both the ways he has explained properly, and he has explained what happens if you know have a concurrent or a blocking statement on all that. You can watch those lectures, right? I've also mentioned the lectures numbers. You can go to the roadmap video and see that, right? Okay, so as a verification engineer, again, you have to make, you have to be, if you're like, when you're writing the codes, if you're interested in writing, testing out all the test cases where it might go wrong, where it might where it might give an error, you're more interested in that sort of a thing, right? You can be a verification engineer. And in verification, trust me, your puzzle solving ability should be very good, right? So I have not seen any verification interview without the interviewer asking a puzzle, because end of the day, they want to see how good is your approach, how well are your debugging skills. So that is the main thing in verification. As a verification engineer, solve as many puzzles as possible. Trust me, I've seen people who are very good with their knowledge. They're good at system verilog and all that, but they lack the basic thinking, for puzzles. So that's where they don't get selected. So that I have seen that. So what I say is, you have to have good puzzle solving ability. That's one way where they can check how is your problem solving ability. So that is a must, I can say, for a verification engineer. At least for all the other roles also they ask, but for a verification engineer, definitely they'll ask you puzzles, for sure they'll ask you, because at the end of the day, in verification, you'll have a lot of test cases, you cannot miss them. And yeah, that is for your verification engineer. RTL design engineer, as I said, you have to know what you're writing, what it is becoming as a hardware. You have to know that, and you have to optimize on power, area, and performance, obviously. So that goes for every role. Then coming to physical design engineer, of course, that's what I do at AMD, right? So when I started, I was working, like, when I started, right, it was already 7 nanometer, and then now 7 nanometer, then 5 nanometer, and then 3 nanometer. So currently in 3 nanometer. Okay, but yeah, PD is again amazing. It comes in the last part of the flow. And yeah, in PD, again, you actually see the design, right? You see the hardware, you see the pins, you see the ports, you see the standard cells. You get to play around with the area. You have to solve the congestion issues, you have to solve your utilization issues, and you will obviously have to take care of your timing and all that stuff, right? So at every stage, and then you have to build your clock. So there are some blocks where you will have to distribute your clock. So the main problem, right, in a chip, right, when you shrink the technology, the main problem is uh, you know uh, how you distribute the clock, right? So as a this thing. Once again. Okay, guys. So, anyways, how is my video? Like, video and audio, is it fine or is it buffering? I want to know. Can you confirm me in the chat, please? Because here it is showing me excellent connection, but uh, please confirm me if it's fine. If there's no buffering issues and all that. Right. It's fine, right? All good. Okay. My audio is fine. My video is also fine. I think everyone is saying it's right? Okay, no problem. So, okay, so PD, you get to see a lot of, you get to solve congestion issues. Congestion is like, you don't have your routing tracks and all that, and utilization is like, it gets clumped in. And where was I was like, at that place, like, CTS, right? So clock distribution. So when you have a chip, right, so the clock, right, as the technology is shrinking, and you are having high frequency clocks, right, so the clock is moving from the source and it's getting distributed across your chip, right? So when you distribute the clock, there's a lot of power getting dissipated. The clock latency is different because it's obviously going through the chip, right? So that is a major challenge in PD, I'll say. So CTS is like one of the most important stage for a physical design engineer. So you get to you have to basically balance the clocks, skew, latencies, and all that, taking care of jitters and all that. So that's a big challenge. So how do you distribute your clock for these shrinker nodes and high frequency clocks? So that's it. Let's not go much deep into that. I'll have a dedicated video for physical design where you can get to know all that. So yeah, so when you're just studying, right, you have to know the basics of CMOS, obviously, and you have to know how an inverter works, inverter characteristics, especially what happens at VDD is equal to VDD by 2 and all that. And then you have to start your flow. Many people just start off right from the flow, like they say floor planning, then placement, CTS, and all that. But before, you need to have your basics right, and then you can start your flow. I always say that if you have your basics right, then that flow is very easy to learn, right? That's not like, it's not a major thing. Just have to know like what happens in placement, what happens in CTS, and all that. So if, see, any day if anyone goes for interviewer, or if I am the interviewer, like the major thing which I will see is, does the person have the right basics? Because if he has the basics, I am very sure that he'll catch up, right? He can do things, because the technology is so fast that it is changing. It is changing so quickly. So you need to have that ability of learning, like that ability of learning is what people see when they hire. So if your basics are strong, that shows that that you have that ability. Because if your basics are strong, then you can learn anything in any amount of time, because you have a strong base, you can build any big building on top of that. Okay, so that was about PD, and that was about VLSI embedded. I think I've talked about my things. You can go ahead and I'll start answering your questions. So, uh, any questions you want to ask, so you can go ahead and ask me. Well, sir, I have one doubt regarding my campus placement. I hope you read this. Give me a suggestion. What is your doubt? But okay, I am from Tripoli. I want to make money in core, or to make money in core. Is it good? Yeah, of course. The see, you never have to see about money, but I can say you that the top semiconductor companies pay very good amount, like yeah. And you can, with the stocks you get, of course, like you seeing, right, Nvidia stocks, AMD stock, all the hardware company stock, even Micron and all that, you can see how it's booming. And then okay, how is physical design with timing analysis in PTL course? For physical design, like I've suggested some websites, right, in my roadmap video. You better, I think there's one blog by Kavita Sharma. I don't remember the name. Kavita Sharma, and like one VLSI backend, right? So that is very good. So the video wise in YouTube, I did not find anything good, especially the NPTEL one is quite outdated, so I'll not recommend that for sure. Okay, then scope for a CSE guy in FPGA stuff. See, CSE guy, I personally don't recommend you to get into VLSI for that matter, because VLSI is more about, it's deep into tech, right? So I recommend you to, for a CSE guy, embedded is very good, because you have to learn electronics for sure. You have to be open for that, but it will not be that this thing. But because I think in CSE curriculum, at my time at least, digital electronics was there, computer architecture was there. So I think CSE guy is good for embedded. In if at all you have to come into the VLSI domain, then I think front end will be better. Okay. Hello sir, I have one doubt regarding my campus placement. I don't know what is your question. How is physical? Okay, this. How is it? So many repeated questions. Tell me about analog electronics. Okay, so see, in all my roadmap videos, in my roadmap VLSI roadmap, I obviously missed out analog. So because analog I can't combine it with digital, right? So I'll have a dedicated analog VLSI video, so you can get to know that. Okay, so yeah, analog video we will have that. For analog, don't worry, you don't have to worry. I think I'm missing out some chats. For analog VLSI, mainly like you have to be good at your network theory. Of course, that is like base for everything, and then you have to be good at your like later you will have to do more of analog stuff, like op amps and all that. So we will have a video, we'll have a dedicated video for that. Don't worry about that for sure. Do you think it's good option to pursue masters in Europe? Mostly thinking of Germany. See, Germany, I don't know, right? Germany, I think it's very good for mechanical side of the thing, but US is, of course, US is great, I think, for VLSI, and VLSI is of course booming everywhere. I think if you have to go for masters, try US. If you don't want to do it in India, obviously, I will obviously recommend or suggest you to try it US. Hey Sanjay, did you manage college with? How did you manage? Yeah, as I said, right, I was lucky that there was COVID that time, so I need not have to go to the labs and all that. So it was, I think it was convenient for me because I was sitting at my home properly, and like everything was convenient. So I was not even listening to my college lectures, and I had like say 3 months. I started preparing it around November or October, and then 3 months, and I solved all the previous gate questions. Like I never wanted like the best rank in gate. I just wanted to get into a top tier 1 college. So I think if you want to get into top tier 1 college, even if you get a rank around 1500 1600, you can get a top tier 1 college, not IITs for sure, but for IITs I think you have to be below 1000. But if you want to get into any top tier 1 college, if you get around below 1800 2000 also, you can get for a general category, of course, you can get into tier 1 college. And once you get into tier 1 college, of course, like if you're good, you will get placed. And yeah, that's how I managed. I just wanted to get a minimum score which will land me into tier 1 college, and I managed that in 3 months of preparation. So mainly you have to go through your you have to go through your topics, and then do each topic wise, do the gate questions. So that is very important. So at my time, when I was solving my gate question, right, the real gate exam, so many of the questions were from the previous year only. So like not the same questions obviously, but the type was the same. Yeah. Okay, so that's how I managed. But many of the people I've seen usually take 1 year drop and then they prepare, because normally you don't have COVID every year, right? So you have to prepare your BTech, you have to do your lab stuff and all that. But to be honest, if you take 3 months, right, and you do all your previous year gate questions properly, then I think, and you're good, like you just don't see the solution into it. You can do that. You can have a timer and you can solve the previous year gate questions properly. I think you can easily get a rank with, like say, within 3 to 4 months of proper dedicated preparation, you can get a rank below 2000, I feel. And if you get a rank below 1500, I'm sure you'll get into MTech in tier 1 college. say IITs, NITs, or sorry, not in IITs, of course, in NITs and BITs or triple ITs, which also has a good placement. So that's not a problem. And also there are some courses like MS in IITs where you get it lower ranks, but the number of years are around 3 years, I think. So that's for your gate. Is the roadmap for triple E BTech third year who wants to go to VLSI electronics? See, the roadmap video what I have shared, right? It's for everyone. So that is for triple E, for electronics, no matter your branch, you have to do that. Just that if your branch has those courses integrated, like in your course and your curriculum, it gets easy because you just have to prepare that and master that. You will not have to do extra stuff. Say if you are from triple E, and because you will have some subjects like machines and some like some subjects like that, obviously that will not be required for your semiconductor industry, so you'll have to even study that for your exams and also study this at the same time. So that's how it gets tough, but the roadmap is what I've shared, so that is the same for any branch. I've started working according to your roadmap for VLSI, but I'm scared about internships. How can I find internship? See, internship is like, you need not see the one mistake what people do is they focus on internships. I want internships in VLSI companies only. It's not like that. See, you can get internships in any company, like say in an embedded company or some things like eYantra and all that, right? So even if you do that, like I never have done an internship from a VLSI company when I was in my college, right? That will also help you, so don't worry about it. You just have to make your base properly, go for internships and have some kind of industry, just know how industry works, right? Even if you do your internship say in some VLSI company, it's good, of course it's good, but the main thing you get to learn is how the industry works there, and some, like say if you're doing some verification role, you get to learn system Verilog, which you can normally work also. So internships, while in college, you just have to work on getting internship in any electronic company. It's not like only VLSI company, and I know in VLSI company to get an internship, it's very tough even for a tier 1 college, right? So yeah, but if you get an internship in VLSI company, right, then your road is like, you are almost in, because most likely if you get a 2 months internship, you will be converted into a 6 months internship, and if you're good, you will get a full-time job. So yeah, edge is there, like you will easily get a job, but it's not that you have to get internship in a VLSI company for that matter. You can get into any company and then you have to know how the industry works, and then you do your things, whatever I have told you, get prepared for that, and then finally apply for the jobs and you will be in. Bro, now I am in BTech second year. Cortex M architecture software development specialization is the specialization recommended for embedded systems? Yes. See, ARM Cortex M, so M class processors, right? That's what people use. So that's the best thing. But before doing that, I hope you have the basics of 8051 and Arduino. People will tell you that that's like useless and all that, but ARM M to start off is little high level thing, according to me at least. So if you can start off with a smaller processors or easier ones like 8051, you get to know how the architecture works in a very easier way, and then you can go to the risk architecture. That's how I will recommend. But if you're doing M class family, right, so that's how the industry is working on M class processors. So you're almost there. So it's very good if you are doing Cortex M architecture. That's very good. So you work on bringing up, how do you bring up a processor? So that's the whole idea. So if you want to get into the semiconductor side as an embedded engineer, or a firmware engineer, if you want to get into semiconductor industry, you have to know, basically your job will be to coordinate with the hardware people and bring up a processor, because once a processor is made, there's a lot of, you can't go back and make the processor again, right? So if software people are involved, you can do multiple pre-silicon checks on your software, and you can do emulations and you can check. And once the chip is made, again you will have to bring it up. You will have to boot up the processor basically. So yeah, so that is your semiconductor industry. And in consumer electronics, you get the ready-made product, you have to deploy it and use. AIML versus embedded, which one I have to choose, sir? Of course, that is based on what interests you more, right? AIML is like you're making LLMs and all that, you're making your neural networks and all that. So that is a different story, and embedded itself is a different story, because in AIML you're more likely going to work in Python, and in embedded you have to master C. So that's like a completely two different things. So you see what you like, right? You like lower level of language and hardware, or do you like AIML stuff? So you have to decide on that. Sir, I am from tier 3 college, 2024 passport. I'm getting trained at Ram University. What can I do to improve and get job? See, whenever you are in a training institute, don't get your hopes very high that you will easily land up into a product based company. The chances of you getting into service based companies more. But then again, like I have said in my many of my videos, that you can actually go there, impress your managers, and you can get into a product based company as a full time. You have to get a starting point. That's the main thing. You have to get into a startup or a service based company, and you have to start off, and then you have to see how the industry is working. Okay, and then the best training is always when you start working. Okay, so yeah, so that is the main thing. How can you improve is mainly what I've seen in training institutes is they don't more focus on your theory, right? Like your theories, they see, of course, being practical is the most important thing end of the day. But if you know a good, if you have a good base, theoretical knowledge, if you have good theoretical knowledge, and then you do practical stuff, you are a much better engineer and you can do things better. So if you're in a training institute, I'll definitely recommend you to go through CMOS and all that by yourself. So that will be better. What to learn in first, second, third year? Again, I have made the roadmap, right? So you can see, like you can in the first year, again, I'll say don't do any stuff, just keep exploring the college, and just see what all you can do, and try to see what all domains are there, what all you can get in. Ask your seniors how your college placements are there, and see what interests you have. Do you want to get into VLSI, embedded, or you want to go to the software side? And then in the second year, accordingly, you start preparing whatever roadmap I've shared. So in second year, you can start off with C programming, digital electronics, and all that stuff. And coming to your third year, you can go into much higher things like computer architecture and Verilog and all that stuff. So that's how you can do. Already I think there's a video on my Insta channel also, and you can see the roadmap video, and you can just align those subjects with your curriculum, and then you can study accordingly. Bro, where to learn the architecture and microarchitecture? Okay, is that? Is that? I missed that question, sorry. So many questions I'm missing. Anyways, Texas Instruments offered 9.2 lakh CTC after 1 year of internship with stipend of this. Who are pursuing the diploma, and is it better to join? Yes, I think if Texas Instruments is giving you, just go. I think, yeah, even if you think the salary is less, just go there, work, and you get the industry experience. That's like, that'll beat everything, right? And prove them that you're worth more. And then I think, see, the industry standard salary is of course more. So if you are good, right, you can easily switch. So there are many companies who will come, and the VLSI world is a very small world, so you can easily switch. But I'll say, if it is TI, just take the offer and go work in the industry. You will have a very good knowledge. Is any private company okay for internships, like paid internships? See, paid internships, I'm not fan of paid internships. I don't really get the concept of paid internships. I don't know why companies ask you to pay and all that. So yeah, but if they're teaching you some industrial tools and all that, then maybe it is good. But paid internships, I don't really recommend. And if a private is any private company okay, obviously you'll be working in most of the private companies also, so that's fine. So please upload proper videos for embedded system. Yeah, I'll do that. My college is giving training for verification engineer. My tie-up VLSI first institute. IIT is good to go for master. See, again, I have made a proper video on whether to do masters or get into a training institute and get into a job. See, the thing is, in training institute, most likely you will get into a startup, not even a startup, I think mostly in a service based company, and you will be working as a contractor. Okay, so your life in the starting years will definitely be very tough, right? You are forget about work life balance and all that, and also obviously your salary will not be that great. But you can obviously, if you are very good, because as a contractor or in service based company, if you're not on the bench, you get to work on all the challenging stuff, because there's no work life balance. You have to keep grinding and working, and you know, if you're good and if you can manage, you get so much skill that the same product based company which was your client sometimes hires you there. So, and at a very good pay. So that is one positive thing about that. And of course, if you do your masters from tier 1 college, you directly land up into very good startups who pay very good, or you can directly get into companies like Nvidia, AMD, TI and all that with a good package, product based companies. So that's upon you, like what you want to do. I made a dedicated video. Please check that out. Bhaiya, I'm currently in second year. Should I do digital IC design and or do grade preparation? See, again, for gate and whatever we are doing, right, there are some common things like digital electronics, analog, network and all that. First you have to finish that, and then do specific things like digital IC design in NPTEL and all that. See, if you are if you're sure that your college, you don't have good placements in your college and you have to go for masters, and you have to do some, you know, uh, yeah, you have to get into some tier 1 college if you're not already, then it's better to start preparing for your gate only, for sure. And then once you get into your masters, then you can do all this, like your NPTEL courses. You'll have like 2 years, like 1 year, you complete 1 year and you can do all that. So don't worry about that. But the basics, right, the basics, when I say digital, analog, again, it's common for everything, right? Computer architecture, common for both gate and your, if you want a job. So first finish off those common topics, and then when you have a clarity, then decide and stick to one single thing. Don't do all of the things. Then don't start preparing for your VLSI companies and gate at the same time. Do one single thing once you finish your basics. Okay. How to be in PCB manufacturing or any other manufacturing companies, as I am from tier 3 college. See, manufacturing is in two types for electronics. One is obviously your PCB manufacturing, and one is your semiconductor manufacturing. Semiconductor manufacturing is like your when you manufacture the chip, right? Your semiconductor chip. So that as a manufacturing semiconductor manufacturing companies, you have companies like TSMC and Global Foundries and all that. So there you have to focus more on a subject called EDC, right? So that is like all about semiconductors. So you have to be very good at EDC. That's the only thing. Like that's your Bible, that's your Bhagavad Gita, everything. EDC. I think EDC, electronic devices, yeah, that thing. So it is more into semiconductor, NP, doping and all that, doping concepts and all that, right? So you have to be very good in that, and if you're good in that, you can get into semiconductor manufacturing, right? And if you have to get into PCB manufacturing, you'll have to know about protocols, right? Like there'll be different protocols like I2C, SPI. Based on that, you'll have to do your PCB design. So obviously you have to be good at analog. You have to know about EMI, EMC and all that. So EM things and all that, right? Your integrity, your signal integrity, your interference and all that. I have covered that in all about all about embedded video. So you can check that out about all about that, right? Yeah, you can check out how you can, as a PCB designer, you have to see EMI, EMC and then design your circuit accordingly, and obviously you have to know about SPI, I2C and all that. Accordingly you have to design that. I've explained that in that video. You can check that out. Bro, my fifth sem just ended. Please tell me how to get internship off campus. See, for off campus, again, you have to build a great network on LinkedIn. The best way is LinkedIn. Go and ask people who are working in embedded companies. Okay, interact with them. Okay, interact with them and try to get a referral. That's the best way, I can say. If you are good, like if your profile in LinkedIn is good, the first thing, okay, so whenever someone asks me a referral, the first thing what I see is does he have a good profile aligned to what job I'll refer him, because end of the day, you know, my credibility is at stake, right? So I don't want to refer someone who is not aligned to the job role what I'll refer him. So obviously you have to take care of that. So first thing is get your LinkedIn right. Go check out your, like say you want a internship at say some embedded company, or say embedded company, you want an internship at embedded company. So check out for the jobs, and see what are the exact requirements, your JD, right, your job description. See there, like what all are the requirements. Say there is requirement of C programming, there is requirement of computer architecture and all that, right? So you you obviously have to work on those projects, or at least show on your LinkedIn that you have worked on those projects, but you have to know about it, you have to have knowledge about it, because in the interviewer they will easily get to know if you really know about that or you're just faking it, right? You align your LinkedIn profile accordingly, according to the job description. And then if you go to that company's LinkedIn page, right, every company has a LinkedIn page, you just go to the LinkedIn page and see the people who are working, and just see how many people in your connections or in your first connections, right, are working in that company, and you message them and ask for a referral. And the first thing they see is your headline, right, like the first headline. If your first headline is very impressive and you send them the link of that job, right, they'll be very much happy to refer you, because at the end of the day even they will get money. Some companies, yeah, they offer, if you refer someone and they get in, they also get money, so even they will be much happy to refer you. So have a good LinkedIn profile, have a good headline, and then you message them on LinkedIn properly, and then tell the reason, like, I'm good at this, I'm good at this, in a very short way. It's not like, you write paras on that, because they are also busy. So in just like, they just see, with a just simple glimpse, they should have an impression that yes, this guy is aligned to the job profile which he has sent me, and I can refer him. So if they get that confidence, they'll easily refer you, and once they refer you, right, your chances of getting a call for the interview is very, very high. So that's the best way you can go ahead. Please share my vacancy updates for Resident Embedded Systems. Okay, you can check out the you can keep following. There are multiple people on LinkedIn who keep posting such things, so you can, best ways to follow them on LinkedIn. Is any internship okay, like private company on this? I have idea about 8051 edit project too. Good. Okay. Texas Instruments, Bio Digital. Third year pass out. I'm trained at Ramya. This was I covered. Where to learn architecture and microarchitecture for ARM without knowing much computer organization. See, without knowing much about computer organization and architecture, why are you going into that stuff? See, first you have to generally learn computer organization and architecture. So, if take a RISC-V processor and you have to learn that. So I have suggested a couple of videos for that, so you can check that out, see how a basic architecture works, and only then you go to the higher architectures. Don't simply jump into something. So first you do your 8051, then you do your RISC-V processor. That's the best thing I'll suggest. Okay. Bro, my fifth sem just ended. Okay, this is done. Good evening, and this is knowledge for analog layout. How can I prepare for that post? Okay, see, for analog, start preparing op-amps and all that properly, because PLL, op-amp, have a project regarding PLL for sure. Okay, and all that, and I'll get a dedicated video for that, but I don't know how fast it will come up, because the next video will be roadmap for embedded, and only after that roadmap for analog will be out. Is any internship okay? Like, there is CDAC in VLSI good. CDAC for VLSI I don't know, but I think CDAC for embedded I've heard a lot. CDAC for VLSI I really don't have any idea. I think you have to check out people who have been in the VLSI industry from CDAC. So if you ask them and ask their review, they are the best people to tell you. Where should I learn VLSI course? I have made a roadmap video. Please check that out. Bhai, I am currently in this I've covered. So many questions are getting repeated. Bro, my fifth sem just ended. I'm missing out the real questions, because please don't spam your questions, right? Please. Embedded EC. What courses after learning embedded? Again, the repeated question. Okay, I'll take the live questions from now. How can I pursue for robotics engineer? I'm in first year from tier 3 college. Okay. Robotics engineer, to be very honest, see, in India, the scope is not that much. So I'll recommend you to start working for your masters, right? So start preparing for your GRE and all if you're in your fourth year, and get a good research paper, get a good reference from a good professor, as I said, like some IIT or IIC professor if he's a very in that particular domain, and then go to US, go to CMU or something like that, and then the robotics scope, or Boston University and all that. The robotics scope there is very good. Unfortunately, right now in India, it's not good. So I'll recommend you to go to US and then do your masters there, and then you can get a job there easily. Then I think you can come back after 10 years here. Then I think it'll catch up within 10 years. For now, it's not good here. So it doesn't. Okay. Okay. So what type of embedded system personal projects are used for entry level embedded jobs? STM32 based self balancing robots LCD. Yeah, see, whenever you make a project, right, the best thing is you have to know in and out about it. Like the what people say you have a very good project but you know nothing about it, and the interviewer will get to know like this. Okay, so no one will be bothered if you've really done that or not, but if you have the knowledge, that will come only if you have really worked on that. That's how the people, and it's very easy for them because they worked for so many years. Usually people who take interviews are like say 10, 15 plus years experienced people, so they'll easily get to know if you've really worked on that or you're just faking it. So the thing is, if say you have made a balancing board, right, so you should know everything about it, like how you use the filters, right, how you use the sensors, how did you use the accelerometer, did you choose accelerometer, gyroscope and all that, and how did you design your controller loop. All that is very important. So if I ask all those questions, and how did you program it, right, and what are the challenges, like how did you configure the I value, how did you configure the P value. You can't just simply say that I just did some random trial and errors. Okay, you did trial and errors, but what changed in the design, like after changing P, what actually changed, and after changing I, what actually changed, after changing D, what kind of impact you were seeing there. You have to tell that properly. So your depth, that is what they see, because they have to train you again. You'll be working on different projects there. So if you have that problem solving ability and you can see things in depth, that's what they see. So you know in and out about that. I am this insurance company to visit a call for an okay, this AEEE and sir, does our final year project matter in interview? Yes, see, all your projects as a fresher, all your projects matter in an interview because the person wants to see how you have contributed in that project. So before that, they'll obviously judge you on your basics. So once they've judged you on your basics and you're good with that, they'll move ahead. And projects is the best way you can make the interview revolve around the things you know, right? So they want to see what you're good at. They just do, because everyone will not know everything, right? So if you are good in say what you have done, because you have done that, so you have to have knowledge about that. That's how they get to know, how is your problem solving ability, how good you can work in a team, what you have contributed and all that. So projects are important, and just not writing projects, you have to know about the projects, and that you will know only if you have worked on that. Okay, so work on the project, then you will actually see the problems there, you will solve them, and that's how you get that ability, that ability to debug, the ability to solve. We when we were making projects, we did an all-nighter and all that, and then you get that, you learn that skill of finding a problem and then how to get the solution for that problem, right? So that will work you in every part of your life. Later also, when you keep working on your industry projects, uh, people will always not keep helping you, they'll be busy in their life, so you have to yourself come up with a solution, so that will help you. So projects are important, yes. Is BHEL in Bangalore good for internships? See, again, if you have to see what they're actually teaching you, or what value are you getting, right? If you're getting some value out of it, then do it. Just because it's BHEL, just because it's ISRO, just because it's DRDO, don't do that. If you there was one of my friend who did his internship in Volvo, and he just did nothing. He just went there, he just sat, and then he just came back. So that is useless. Okay, you have to know stuff. You have to that has to give you some kind of value. It has to add value to you. That's how it is good. So tomorrow when you go for the interview, they'll ask you, what did you do at BHEL? And if you can't say anything there, then it's useless. It's better to remove that from your resume. If you have done something really good, then it's good. Good evening, sir. Okay. Mm, I want to get into the embedded engineer. Please suggest me the road and syllabus, books, and YouTube classes. Okay, I'm making a video on that. Scope of backlogs or results matter for getting job. See, that's what. Sometimes it matters because every company wants you to clear your backlogs and get in. Okay, so if you don't have any current backlog, that's always an advantage for a company, because they know that again you will not be preparing and wasting time in your curriculum. So you will easily get a job. So that's the thing. Okay, so I think we're already 6:20, right? So we'll just close this live session. It was good, right? It was good talking to you. And the main takeaway is work on your projects. Projects is a very important thing as a fresher, right? And that's a great thing for you to work. So if you are good at projects, then you can display that in your resume only if you have actually worked and there's some value added to your some value added to your knowledge. So if you are good at that, you can actually showcase that in your resume, and if they ask you, you will be able to answer the questions. Okay, Akshay Sheth has asked me, sir, ATML or embedded, which one has a good future? AIML or embedded? So, okay, I've answered this question. Okay. Okay, guys. So, I think we can stop this, right? Work on good projects. The takeaways, of course, work on your base. Have a good base. Do all the basics of your electronics and all that, and then do good projects. When I say do good projects, have in and out information about that. Just don't be a teammate who does not contribute and all that. The interviewer will easily catch you. And certification courses, I don't really recommend. You don't really require any course which has a certificate. No one really cares. If you have got the knowledge from that course, if you have the right skills, that's what people care at the end of the day. Okay, guys, thank you. So we'll close this session. Thank you so much for joining, and that's it for the session. We'll have a roadmap video soon. Thank you, guys. Thank you.